Alright, time for another DraftScience video presentation. So we'll do some brozo comments on the 1 minute video regarding his 1 minute video. This is really pathetic. The 1 minute videos that prove something that's never been proven yet, okay, by any experiments. They're all so happy with themselves and they're all satisfied. So anyway, just like Piro's all satisfied with really stupid logic. So he made it one of his, his shows that don't make any sense at all. There's more time going into the show than there is show. There's no subject, and they're really slow. So anyway, so Piro says that there's something called logic. Okay, it's kind of important. In the same kind of connected subjects, he talks about his little version of physics, which is kind of hilarious. But anyway, and that there's people need to know these things. So you need to know all this woo physics. Because it's really important philosophically in terms of logically understanding. And that's just really irritating. So what this all, how this started, okay, is the idea that gravity was figured out, okay, and then Newton gave it a number, 9.8 meters per second, right? But, okay, somehow saying 9.8 meters per second, that is, it's always affecting you every second, you could sort of figure that out. This is per second. It's 9.8 meters per second. Well, somehow they needed to square that, just so you'd understand it's per second, like every second you're in the gravity, it's happening, which you already know, right? That's not going to be confusing. It doesn't happen in 1 second, there's no more gravity, it's continuous. So that is where the whole thing goes south, is when they put that square on there for per second. It doesn't mean you square 9.8. It doesn't mean it's whatever that would be, 100 almost meters per second. That's not what this square is saying, But when they do their fake math, they say Newton would have done, which obviously Newton wouldn't have done it, they find an excuse to do that because they call this acceleration. So see, that's a rate. If you're going to say 9.8 meters per second, and use this notation. So the notation they use for squaring something is the same notation they're using for it's per second. That's where they got into trouble. Well, that's where they manipulated you. That's where they contrive their bullshit. Okay, so does not mean you square this number. All right, even though it looks like that's what it means, that's not what it means. All right, and so then when they do their math, they come up with this contrivance. Okay, so even though Newton didn't say F equals ma, and Newton said F equals the change in your momentum, okay, this is what Newton said. F equals the change in your momentum, okay, over time. Not time squared. Not. So if I said seconds here, okay, I'm going to cut it to units of seconds. Okay, so time is going to be in seconds. It's not seconds squared, right? I don't sit there and square the seconds. That would be silly. It's per second. So if it's 16 seconds, then I divide the 16 into this number, and I get per second how much force there is per second. So if the experiment lasted 16 seconds and I put the 16 in there, this tells me there's 16 units of this amount of F. I could just say, well, let's just hell with it. I know the experiment took 16 seconds. How much is the total amount of time? Well, then that's a unit of 1, and I know it's 16, so I can just say, what's the total change in my momentum? And then I'll get a total change for F. So I won't have to do this stupid per second stuff, and I won't get confused. So that's Newton's equation anyway. So it doesn't have anything to do with any kind of notion of creating an acceleration squared. And that's what they do. So they say that acceleration is time squared. Okay, so if they say it's 8, the acceleration is 8. 8 units of energy per second. Well, they put this square on it to say it's per second. because as long as you're in it, it's going to affect you that much by your acceleration, because it's at a rate. But the rate isn't squaring the 8. So that's where their math, their derivation, goes all kinds of south. So again, just understand that you can simply understand that this is the simplest form of the equation. Okay, just doing this, saying, all right, I don't care about the units of time, because I'm just saying I'm doing an experiment. I want to know the total force that affected the object. Well, then I've gotten rid of this idiotic fraction, okay, so it doesn't confuse you anymore. And all I have is change in m. I'll get rid of the p and put v there, because that's what the p is, just your mass times your velocity. So that's all I've got. Now, a change is just like, well, who cares? Because I could also just say the thing was standing still. So just tell me what's my mv, and that'll tell me exactly what the force is. So the force, okay, is on one side of the scale, all right? We made a little scale, okay? And the fact is your energy, or I could replace that with energy, or I could replace that with momentum. Oh, well. It's there. There's a little p over here. They're all equal. It's all the same thing. And this squaring nonsense, again, holdover from Leibniz. This isn't Newton's physics. Okay, kinetic energy formula is not Newton's physics. It's just a terrible lie against Newton, a poor dead guy. Nobody here to defend him except for me, apparently. So Newton didn't say any of this nonsense. Newton didn't believe any of this nonsense. Newton opposed this nonsense. This was the idea, okay, of a guy who was overtly religious, overtly said to physics, you're too atheist, your physics is too, it doesn't have enough God in it, okay? I don't see any souls in it. I don't see any, magic bits, okay? So Newton's equation was F equals mv, and their equation, the Leibniz equation, was mv squared. And then 100 years later, they changed it to 1/2 mv squared. But understand, that's the truth. And when they keep lying, okay, that this crap is classical, okay, that is having something to do with Newton, it's just such a lie, okay, because it's exactly anti-Newton. Just like wave theory is anti-Newton, just all that stuff. It's all anti-Newton, and they keep pretending it has something to do with Newton's reliable working math. Okay, and we know the space guys don't use this horse shit because it wouldn't work. So it's that true. And, we just have to get one of those guys to admit, oh, of course, when we're navigating in space, we don't bother with that mv squared thing, 1/2 mv squared, because that would make us crash into things. Instead of getting right answers, we'd get wrong answers. All right, so these idiots don't do any theory. So they don't explain anything to you, right? So I'm trying to say, okay, we can do this simple little logic of taking bowling balls, okay, and have a 16 and an 8-pound ball, okay, and we can give them proportional velocities of 8 and 16, and you can understand what they're going to do when they hit an object, and that heavy objects will reliably give their momentum, their velocity, to lighter objects. So if we have 4-pound pins, as I pointed out, you can simply understand that the 8-pound ball, okay, all it can do is give a velocity, the 8-pound ball going 16, okay, so this is miles per hour, sorry. How did I do that? It's a lot of work getting all this stuff right on the fly. So the 8-pound ball going 16, so it has a velocity of 16. I gotta make that clear. It can give 16, almost. So just think about how velocity is exchanged. See, they don't do any theory at all. Stephen Bro will never explain how energy is transferred between one object and another object. He'll give you no explanation at all. Nothing. Zero. So what's their theory? How do they think it actually happens? Anyway, so it has this x16 velocity. And the fact is, it can, because the pin's lighter, it will take its momentum and put it into this object. Its momentum will go into the object. Just like if the two kinetic balls, pool balls, hit each other and they have the same mass, they'll just exchange this one will leave and this one will stay. So you'll completely transfer the energy from one to the other. Well, the same thing's happening here. It's just that the transfer can't be complete. So you have to do a little math. You have to do a little figuring. So anyway, so as the 8-pound ball starts putting the 16 velocity in, you can sort of understand that the velocity is going to have to decline because it can't change the mass. So all of the energy it puts in, it has to take it out of the velocity. So you can just do the math. I should have done that ahead of time again, right? Pathetic. 64 and 64 is 128. So the total is 128 of momentum. So you have 128 to deal with, mass times velocity. So when you hit the 4, it's half the mass of the 8. So, and you can give it almost 16. So let's just say, for the sake of argument, you gave it the full 16. It'll be a little less than that. That's 64. So half your energy is now lost. You only got 64 left. And obviously in this other scenario, it's going to be 32, and you're going to have 3/4 of your energy left. You're going to have whatever it is, 90 something, 90 whatever, 3, we'll say. So you still have more momentum, but the pin has less. So this pin leaves at 8, this pin leaves at 16. And that'll be how these two give away their momentum. And so let's understand, once they get to a point where this one's going slower than this one, right? Because it gave away so much to this first pin, so now it's only going 8 miles an hour, right? It gave away half its energy, so it's down to 8, which is the same as this. But the trick is, it's down to 8 and still only weighs 8 pounds. This one weighs 16. So obviously any total number they have left, so let's say there's a point where this one has 64, and so this one hit 2 pins, and now it only has 64. So they have the same amount of momentum, 64. So their speeds have now been changed to the same speed. Well, this one hasn't lost that much speed, so I can't make them the same speed. But anyway, the point would be is that this one, because of its greater mass, can store a greater amount of its momentum in that mass, which means it can keep giving away energy where this one won't be able to anymore because it doesn't have a dense enough mass. So it's going to keep losing more velocity. So this one will actually start slowing down faster than this one slows down. So even though this one went fast going in, it'll rapidly decline in its speed, and this one will maintain its speed for a longer duration, but it's going slower initially. And they end up doing the same amount of work in the universe. And that's the key point. They have a certain amount of momentum. Doesn't matter what they hit. It just matters how much velocity and mass it has when it leaves. That's deciding what it can do in the future. And so you can do this with trains. You can do this with anything, in the sense of you can understand that I could take 2 trains that are going 25 miles an hour and have 1 car behind them. And I could just make one train go, 12 miles an hour and add another car, double its weight. And then I could add, you could have a train that has 500 cars going 5 miles an hour, and a train that has, 20 cars going 30 miles an hour. And you could say, yeah, they'll do the same work in the universe. It would be wrong to think one of them has more actual energy. One of them's going faster, so you know that if you stick your hand out, one of them's going to give your hand a whap. It might even knock your arm off because it's going fast enough to do that. But it doesn't mean, if you keep putting barriers in front of it, that it's going to knock over more real barriers. So I've tried to make this understandable that no wrecking ball company uses the twice as light wrecking ball. Okay. No ship in war uses the twice as light cannonball. No catapulter, of ancient times used smaller catapults, with higher velocity that shot less massive objects, because there was no advantage. Faster things don't make more energy. Momentum is energy, so it matters how much you weigh, and they're equal. Mass and velocity are equal contributors to energy. Okay. I mean, I've done a lot of this before, but I'm just trying to make sure there's a context understanding that, I'm not the one evading, doing experiments correctly or analyzing the world correctly. They're the ones evading. So they make these claims that this stuff exists, but they'll never show it. So the point is none of these experiments have been done. They haven't taken things that are twice as massive and going half the speed and actually done the experiment to demonstrate how much energy they have, how much they can change the world. They haven't even done it with analysis of a thing like a bullet, right? Bullets transfer their energy very quickly because they're going fast, so the things right next to them go away very fast, but that speed dissipates, and that's the whole point, is that speed isn't energy. It also means your mass is just as important. How many pieces do you have to push with? It's not just about how fast they're pushing. It's about how much mass they can push with. Yeah, I mean, I've already been over this so many times. Anyway. All right, so Stephen Bro says, well, I think that's an excellent conclusion. So it's just somebody saying, oh, what a, 1 minute video, you proved it has more energy. When clearly the experiment wasn't measuring the total energy. It was just measuring how fast the first pin leaves. So yeah, the 8-pound ball wins. If all you're going to measure is how much energy does the first pin have, clearly the 8-pound ball wins. But that's not the contest we're supposed to be in. We're supposed to be in the contest of measuring how many total pins, how much total pin mass moved, how much velocity. And in that contest, there's not going to be a winner because they have the same energy. Alright, I appreciate the effort in making the argument more concise and clear. So there was nothing about making anything concise. He used very deceptive language, actually. Where he puts a little phrase in there, for the duration of the video clip. Well, the duration of the video clip isn't the experiment. Anyway, even if I could win $1 million, so these are funny lines, $1 somehow concocting an argument in support of the opposite conclusion and be absolutely truthful, I would be happy to lie for $1 million and give it to charity. So he keeps mentioning these charities. What charity would you give the money to? I mean, that's a whole theory. There's a whole theory that charity is, a good thing. Charity spends most of the money. I mean, most charities are not only 50% inefficient, they're somewhere in like the 80 and 90% range. So you give them $1, and you're hoping to get some money over here, $1 of good, happening for the things being charitied, Well, they rip this dollar into pieces, and by the time it gets here, there's 10 cents. All right, that's the fact. That's how charities work. They're really inefficient at making this go here. And even when they get it there in some kind of stupid way. Like, Doctors Without Borders will go all the way across the world, right, the earth, to sit there and go to some starving country and help a woman have a baby. Yeah, they'll do this. They'll go all the way across the world, to give them fertility pills or something, when they're all starving to death because they ate all the trees, and they ate all the dogs, and they ate all the cats, and they ate all the rats, and they ate everything, and they don't have any food. And they'll go over there and help them have some kids. Because, yeah, that's being nice. No, that's being stupid. Really, really. And they'll spend like $1 million. It'll be a $1 million baby born in, starving land. They'll spend $1 million, get on an airplane, get another airplane, get some shots. Oh, that doctor died of whatever typhus, so send a new doctor. Okay, fly, go airports, luggage, hotels, blah, 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 blah. That's where your charity's going. Stupid is the word for that. So anyway, I mean, every word, every sentence he puts together is just so full of shit. All right, so he'd be happy to lie for me. What kind of lies would you be willing to tell? I mean, how exactly malicious would they be? How destructive to, humanity? I mean, what is this? Some like any? You'll lie for a toxic waste dump polluter? I mean, what kind of people will you lie for? I cannot think of how I could possibly come up with any such argument. So he's happy to lie for $1 million, and he can't imagine that it could possibly be possible that momentum is energy. He thinks it's that impossible. I mean, even though it really does work, and Newton proved its works, and even the spaceship argument is so obvious. I mean, God, do we have to do that again? Oh, good. Ugh. All right, I mean, you shoot, the dime out here, okay, 1,000 times lighter, right? So let's just understand, it weighs 1/1000th of what the 2 kilos you're going to shove out this side. The big brick you're going to shove out here going 1 mile an hour. So you're going to have, this thing's going to be going 1,000 miles an hour, and this one's going to be going 1 mile an hour. But this is tiny, and this is big, 1,000 times bigger, 1,000 times more soldier. This has 1 soldier, this has 1,000 soldiers. Atoms. Huge difference. Okay, gigantic difference. You say this one has 2,000 joules of energy, and you say this one has 2. So, sorry, I mean, and you think it's laughable for me to laugh at that. To think that theory is the one that, shit, I couldn't even, you could give me $1 million to pretend my brain could actually make that make sense. Just like I could say, I could lie about 2 + 2 = 4. And for $1 million, I'll say it equals 3. I could say it, but I could never believe it. So for $1 million, I could never believe it. And I can never believe this nonsense that somehow the same explosion, okay, we have a little explosion in here, shot the dime this way, and it shot the 2 kilos that way. You're saying this is 2,000 joules of energy. You could do all kinds of charity work with that. It's lots of energy to fly doctors to go make babies. And you only have 2 here. You couldn't barely get the guys you couldn't even send the doctor's shoe. Just sending his shoe would be more than 2 joules of energy. So there's no way you're going to get any doctor anywhere with that 2 little measly joules. Same explosion. Same energy went in. You say this preposterous amount popped out here, and this meager amount popped out over here. And you say, it's impossible for you to understand how I could believe this. Well, maybe you need to draw it and explain to me how, hey, it's 2,000 joules. It really is. And the spaceship went way over here because all this energy flew over this way from the explosion. Somehow the explosion knew, put 2,000 joules that way because it's only a dime. And yeah, don't put, 2 joules over there because fuck it. It's a big heavy thing. We don't want to push that. Somehow the explosion knows how to do that. The explosion isn't actually forces, little bits of stuff, bowling balls, flying off, and the little bowling balls have to hit things. And somehow you're saying the bowling balls knew before they left the explosion, the little bowling balls knew, fuck that guy, we don't want to hit him. We're going to go this way instead. So before the explosion, somehow they already knew, no, everybody pile up on this side of the explosion over here. Okay, because we don't want to get shot that way. Oh, fuck that. No, we want to go this way so we can make 2,000 joules of energy. You think that happened? You think that's illogical? Fuck you, you're an idiot. I mean, I've properly defined you. So he's saying it's inconceivable, okay, that Newton was right. That even though Newton's physics completely worked, And Newton seemed to know what he was fucking talking about. It's inconceivable physics. He can't even conceive of it, even though Newton actually did predict Halley's Comet, you know, not in his lifetime, of course, but he predicted it. His mechanics predicted it. Even though it works, fuck it. I can't imagine how it works because it's silly. That's what you're saying, Steve. You can't imagine how Newton could have been right. You need $1 million to even pretend to think he was right. And instead, the religious kook who believed in monads and solitons, he was on target. And the lady doing the clay experiments, but we all know clay is so reliable. Clay always tells you the truth. You want to know the truth? You just go to Mr. Clay, and he'll tell you the truth. Anyway, Gary, however, has a strange talent for warping logic and history. Bullshit there. So I'm doing it to be too... so I'm not doing, I guess he means going, to be too surprised when he claims it was the wrong sort of bulb. Well, I didn't claim that. I claimed you can't collect the whole energy by collecting part of the energy. That's what I claimed. Okay. The wrong sort of darkness, the wrong sort of velocities. Well, it would be interesting to at least know how you contrived the velocities, because that's relevant to other experiments you've done. I mean, was it a spring? Okay, I was wearing the wrong sort of socks. Well, I'm sure you weren't wearing any. Just like his stupid claim, I put the spring in the wrong place in the so-called 1.4 thing. Well, I didn't say you did. What I said was I speculated as to whether it made a difference. See, this is how he perverts things. So it's stupid for anybody to think it makes a difference. Now let's go back to the Professor Lewin. See, he never responds to a single one of these points. He just characterizes them. But he doesn't actually respond to them. So Professor Lewin did an experiment where he had a spring on both objects. Right? So the one that has the momentum, so one spring has momentum going in, one spring doesn't. Sort of interesting. And you still say, why you need two springs, right? Because the two springs are just going to combine and do one spring's worth of work, right? There's not going to be two. It can't make a difference, right? If I took this spring off, would it really make... See, this is a two-mass object. This is a one-mass object. And he's going to collide the moving one mass into the still two mass, and he's going to get 3/4 of the velocity back, which is impossible. Which is just silly, right? It can't happen. I guess I could just do this. So this should be 1/2, obviously. Obviously, by Newton, by his own rules, where he puts things in boxes, you know, formulas in boxes, and he put a box formula. It says it can only be 1/2. Okay, twice the mass, half the velocity. Says it really loud. Emphasizes it, important, 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 and then it's not important. But that's not a problem. Physics doing that, physics saying it's important, 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 and then not important, no, that doesn't mean anything. Physics saying I'm going to use the squared symbol for per second, okay, to say per second, I'm going to use the squared symbol, and that'll give me an excuse later to just square 9.8 when I'm not supposed to square 9.8. Anyway. So I brought up the issue because he had cars that were going to hit a spring, that it makes a difference maybe whether the spring is attached. Okay, so let's say you're just going to hit a wall, right? Would it matter whether the spring was attached to the wall or attached to the moving object? And I would argue that physics, you know, it might make a difference. That's all I did. Okay, so he turns the story into something completely different. That's all. All I did was speculate that maybe that could make a difference. Now, what really made a difference in this 1.4 thing that he keeps evading is that there's a thing called the spring constant, okay, which equals stiffness, okay, and stiffness equals velocity with springs. So how fast the spring can move has something to do actually with how much velocity it can give something. So when it's going to release its energy, if the spring constant is too low, if it's not stiff enough. See, Professor Lewin used really stiff spring, a bent piece of metal, very stiff, high K. So if stiffness has to do with velocity. So if you want something to move fast, you have to use a spring that can unravel fast. And if you don't, then the spring can have the energy, but it can't give it to the object because it can never get up to the velocity necessary to push the object. So the energy is not going to get out of the spring fast enough, and so the object is going to lumber away at the wrong velocity because the spring couldn't deliver the energy. It's a fact. It's just a fact of springs. They do have these conditions under which they operate, just like the clay can be cold or it can be warm. Well, springs can be stiff or they can be kind of loose. But those facts don't matter to Steve, and he complains to me because I raised the fact that maybe those conditions make a point. Maybe they're important. Okay. Anyway. All right, that got buried pretty quickly by him. So he says here, experiments, by putting it where he said would give a different result. It didn't. I didn't say it would give a different result. I speculated as to the possibility of that being a factor you didn't consider. And the fact is, there are factors you don't consider in every single one of your experiments. They're all flawed by the fact that you didn't consider a factor. And then sometimes you overtly do consider it, like when you drop sticks into the cornstarch, when you didn't drop sticks into clay. So how come you changed that experiment? How come you changed the conditions so dramatically? I mean, a little change I can understand. A big change, why the big change? Okay, just like his stupid excuse that I didn't totally block off the output from the 2 microwave transmitter horns. So see, he does this too, where he always is changing subjects. So we'll change the subject a little bit. All right, so there's been lots of... The simple truth is this microwave thing, again, illustrates the 2 slit experiment in some ways. They're both photon experiments, right? But it's such a different kind of photon experiment that, it isn't really comparable. So in microwaves, you don't need to use slits. You don't have to actually cut something out and make a 2-slit pattern because we can actually have them in phase as sources. So we can send the same signal to 2 different sources. It's in phase. The waves are in phase. All right, so you don't need slits. Now the trick is if you don't use slits, then what's your cause of the wave function, right? Because we're saying that we can't shoot 2 lasers at each other, right? We can't take 2 laser beams from separate lasers and shoot them and cause any of these effects, okay? So it doesn't work with photons unless we put a slit, okay? So we're taking the single source and breaking it into 2 sources. But anyway, so you're arguing is, the idea is that the same thing happens, that these 2 waves fly out here and then in space they interfere with each other and make places where there can't be any signal. Now the simple truth is, now Stephen won't concede, so he's never stated it. The fact is that the geometry for jamming a radio signal, that is where you just take 2 signals and place them on top of each other at the same time, out of phase, right? And that will effectively make it so you can't receive either radio station. So if I have 300 megahertz here and 300 megahertz here, and I put the 2 signals out of phase, the radio will pick up nothing, okay? It just can't pick up either signal. So nothing you'll get. Now he won't concede that the jamming geometry is exactly the same. No difference. Exactly the same geometry creates jamming as an explanation for the outcome. So there is a real reason, okay, to say, well, how can we tease that out? How can we tease out the difference between jamming and not jamming? Okay, because jamming happens at the target. All right, the signals both get to the antenna, but wave interference is supposed to happen here. So the two signals don't get to the target. It's the whole argument. So if they interfere, I shouldn't be able to in any way reconstruct from here this signal at the dead spot. So I shouldn't be able to turn, okay, the antenna directional. Now if I did it with radio, I think Steve knows. The truth is I have two signals coming in, and if I put a directional antenna here and I look that way at the 300 megahertz, I'll get the signal fine. And if I flip it around, look this way, I'll see that signal fine. I'll defeat the jamming if I just use a directional antenna. I think Stephen would concede this argument, that that's a way of knowing it's not jamming the signal. I mean, that it is jamming. It's just use a directional antenna. Now, another argument I can make to Steve is, if it's just the fact that these two signals will cross each other, that is, they'll bang into each other, then if I just shot them this way, and I shot them this way, shouldn't they deconstruct? Shouldn't they crash here in the middle and cause some defect in the signal? But I'm quite sure if I put a detector here, and I put a detector here, I'll see these signals just fine. All of the signal from here will get right through and hit here, and all of the signal from here will hit right here. So I'm sure he'll concede, maybe he will anyway, that depending on where I go, okay, again, just understand that this has to be blocked and this has to be blocked. That these signals did get to these locations. They're getting to the location. They're getting to the target just fine. And all they are is indecipherable because their frequencies are competing with each other. Their frequencies, all of our detectors for radio signal can't detect any signal. They have to tune to a signal. So they're very narrow in what they can perceive. So if you change the frequency in any way, they're out of luck. And of course, if you send competing frequencies, they're out of luck. Because they just can't, they can't, when you combine the frequency into some new frequency, so the energy is coming in, and you can see it if it's in this pattern, okay, but if I combine two signals and it's sending this, you know, what's the radio receiver going to see? The radio receiver is just going to see this on a straight line. You know, this is the frequency it's going to see. You know, and so it's not going to do it any good. And this could be closer to this side, so it could be even more. It could be like that. So it's going to see this. That's not this. So these arguments have been made numerous times with no counter argument. So will Steve, for $1, tell the truth and admit that the geometry for jamming is exactly the same geometry? It's just phase arguments. In phase, out of phase. You don't jam it if you're in phase. So if you happen to have two radio stations that are playing different songs, and they happen to be, just by chance, in phase, okay, in terms of the megahertz signal, the carrier signals are exactly in phase, you'll actually hear both songs. But what's the odds of being 100% in phase? Oh, not very good. Well, you just move a little, right? So if you move a little, you'll actually be able to do that probably. There should be some point. I'm just trying to think. Yeah, no, it's still not going to do any good because every time you move, you're changing both signals. So you still can't fix that the one source is out of phase with the other source. You can't force the sources to be back in phase, I don't think. Well, whatever. I have to think on that. See, it does require some thought, all of this. It's physics, and Steve wants to make it into peanut butter and jelly sandwiches. It's a little more complicated than peanut butter and jelly sandwiches, moron. Alright, so in completely unscientific terms, I like this line. It just seems to me, so how many times have I argued about this seems to me science? I mean, this is Piro's line. Seems to me, after all these similar tests of fast light things versus slow heavy, the fast light things have more oomph. So that's his experience with reality. Now the wrecking ball company guys, their experience is that the heavy thing has more oomph. Okay, the slow heavy thing, more oomph. The cannonball guys, well, they say, yeah, the big cannonball, more oomph. The catapult people, yeah, put a cow on the catapult. Really good. Okay, don't put sheep on it. Don't work as good. So there, I invented a new word for energy. LOL. Huh, funny. Like the word oomph has been around like, what, 300 years? Who knows? Anyway, but seriously, now I've witnessed the first hand in so many instances that Gary is desperate to dismiss with laughable reasons that have all turned out to be false. So this is the big, this is the $1 million lie in this whole thing. So where did you prove it to be false that when you lifted a very light object, the little pawn piece, that you defeated the experiment because you gave the pawn piece lift-off velocity? Okay, so it wasn't being pulled. The energy didn't need to pull on it anymore to get it to go higher because your initial amount of velocity was higher. So you weren't getting defeated by gravity. You defeated part of the friction. So it's really an experiment demonstrating that you can defeat friction. And that's the whole argument being made here over and over again. Again, no concession from these people. The simple argument that the karate guy, okay, who punches through the board, isn't utilizing more energy. He's using the energy more efficiently by taking advantage of the fact that the board's friction breaks. So if I take all day to try to break the board with constant pressure, I'll get nowhere. But if I hit it with one good, fast jolt, I'll break all the fibers and win. That this is a fact of all of these experiments, that friction is variable based on speed, and that it tends to have biases for speed. Now, in the case of cornstarch, the bias is opposite. And other things can be found that have an opposite bias. So this is what they're just totally denying, that there's a huge difference in what oomph you're going to see, okay, based on the fact that, like aluminum, it doesn't bend too good. It breaks good. Okay, so if you get to breaking speed, you can plow through lots of aluminum, all right? But if you don't, and you go to bending speed, well, then you're going to do a lot more work. And those are just, that's physical fact. And so they're just denying all of that context for all of these experiments. All of them have to be done with that understood. Clearly in the early experiments he didn't even know what, he didn't know what the fact is when you rotate something, so he's relying on a rolling piece of a round ball to absorb the momentum. And what he doesn't realize is that the momentum's being converted into rotational energy, not forward velocity. And the rotational energy is impossible to collect. So if I go, not impossible, but if I try to collect it with a little plunger and a spring, it's not going to work because it's going to push the plunger down. It's not going to push the plunger forward. The rotational energy isn't going to be converted into linear motion in the direction of the initial source. So the initial source velocity is partially converted. Okay, so this velocity, this portion is diminished. The stuff going that way is diminished because you're creating rotational momentum, and the rotational momentum can't be collected as easily. You have to collect it kind of carefully to be able to realize that your part of your velocity has now been converted into rotational energy. But it came out of your velocity. It came out of the same amount of energy went in. And now you have less energy going this way, and you have a percentage of your energy built up in the rotational energy. These are physics, Again, it's not peanut butter and jelly. So anyway. Let's see. It now really does feel intuitively correct when those faster, lighter things do more work. So there's no experimental evidence of them ever doing more work. So they just keep saying it, and they don't prove it. That's all you know. How many times do you have to just say the same thing? The very fact that we're having this dispute is demonstrated by the fact that there is no physical evidence of 4 times more gasoline to go 60 miles an hour than 30 miles an hour. There is no physical evidence supporting your theory. That's why the conversation exists, is because you can't just point to it. You can't just link to the physical evidence because you don't have any. And then you're trying to contrive it right here in front of us by doing really crappy experiments where you didn't consider any of the effects that are real. The fact that springs have conditions under which they function. Clay has conditions under which it functions. All of these things have variables that affect them. And you've just pretended those variables are for you to exploit, not to understand. Alright, if you have a robotic shovel clearing snow from your drive, the slow heavy one exerts its kinetic energy, while the light fast one still has more to give. What the fuck? Well, Gary seems to imply he would pay the same for one as the other. Yes, I am going to pay the same because they're going to use the fuel the same, even though one cleared his drive quicker. So he says the quick one lasts just as long. That's how stupid he is. So he thinks the 8-pound ball goes just as far into the pins as the 16-pound ball, when clearly you understand that no, it runs out of energy much quicker, the faster 8-pound ball. I keep wrongly thinking all we need is one great explanation example. You have no explanation, so let's just understand they have never explained anything. They've never showed a bowling ball hitting a pin, diagrammed a model of how energy is transferred. So just like in the physics girl experiment, where she said, look, 5-ton train connects to another train, which is the same as dropping a weight on top of the train. You double its mass and it loses half its energy. She didn't diagram any deformation. She showed us a picture of like a tomato getting exploded by a ping pong ball or something. She didn't show us how the energy was broken or destroyed. So all of the momentum went into the new object. It has exactly the same momentum. So everything had to go into it, because how can, like the bowling ball, how can I hit the pin and have the same momentum for the next pin? It's not possible I have the same momentum. I had to lose my momentum. Well, if you deformed something, if you broke something, if you made sound, the energy had to come out of your energy. You can't understand that concept, Steve? You're telling me you honestly find that insanely silly talk? It's insanely silly to say there's an MV, okay? You have a mass and a velocity. If anything's coming out, sound waves, heat into the ground, the train has a big dent in it, you don't understand that if I have the same MV over here, mass times velocity, that I had to lose some MV. I have to lose it to make a dent. I have to lose it to send this stuff over here. I have to lose it to go into the friction. You don't understand that simple concept. You're telling me you honestly don't understand how you have to lose momentum. That the 8-pound ball can't hit the first pin, shoot it off at 64 momentums, okay, or at 16 miles an hour, and this bowling ball still goes the same speed. It doesn't have to lose any momentum. Its MV stays the same, and it makes the pin shoot off. Come on. You're pathetically stupid. All right. All we need is one great explanation example. Yeah, and you keep contriving them rather than understanding that an example requires a little bit of extra thought. You have to be careful how you produce your example. But that isn't the problem. Gary is the problem. This is his religion. So we know the truth is exactly the opposite. I mean, it's overtly in the historical record. MV squared is the religious theory by the overtly religious guy who overtly found Newton's physics too atheist. That's the word he used. It's too atheist. So let's understand, that's the real history. All right, and so he has no evidence that I'm basing this on some extraordinary theory of gods and special. Obviously, the mv squared part is special. The squaring of the velocity is the special part that can't just... Why is it the velocity squared? Why isn't mass and velocity equally important? So they're the one that are anti-Newton. They're the ones supporting the religious theory. And clearly, the religion of the 8-pound ball didn't lose any momentum. It hit a pin, made it fly off, and the 8-pound ball still has all of its momentum. That's the physics girl theory. All the momentum is transferred, but somehow I made sound, and I made heat, and I ripped the front off the train. Sure you did. All right, that's probably enough. Okay, so yeah, so what a waste of time. These people, I mean, it's a waste of time talking to the trolls, but that's all there are right now. And it's sad that there's so few people interested in physics. I mean, you really just can't find people who will interact on the subject in any kind of comprehensive, reasonable way. They won't respond to what you actually say. All they want to do is quote mine and play games with words, but don't get anywhere near a concept. And it's just really disappointing, frankly. But I always knew it was a bug planet. I just didn't think it was this buggy. I mean, you're not even interesting bugs. You're like the scuzzy, maggoty kind. Eesh. Yeah. No butterflies involved. Alright. Till the next time and such. So this has been a DraftScience video presentation. Thank you. Maybe. I don't know. Well, it's not much to thank you for, frankly. You don't make any contributions. Nobody's doing anything. Except for like 4 people that are doing, But the rest of you, fuck you. You're so useless. No help at all.